The last gas law we're going to talk about in this unit is called the ideal gas law. So the ideal gas law looks at pressure, volume, moles, and temperature as well. The difference between this one and the combined gas law, though, is instead of looking at two pressures, two temperatures, two volumes, we're just looking at one. So this is the equation we're going to use. PV equals nRT. Everything is the same: pressure, volume, moles, and temperature, except for this guy, this R. So R is what we're going to call our ideal gas constant. We'll talk about that in just a second. So some notes for this. Again, your temperature has to be in Kelvin. Make sure you're converting it by adding 273 if they give it to you in Celsius. Something new, your volume has to be in liters. So we can't do milliliters. It has to be in liters. Look out for that. And then we're going to talk about this R value. So my R depends on the unit of pressure. So if my unit of pressure is in atmospheres, my R constant, my number is going to be 0.0821. If it's in kPa, my number is 8.31. And if it's measured in millimeters of mercury, my R is 62.4. But it's just a number, so we're just going to need to know which number to use. So let's do some practice problems. Number 1 says a rigid steel container, like a gas cylinder, with a volume of 25 liters is filled with nitrogen gas to a final pressure of 200 atmospheres at 27 degrees C. How many moles of nitrogen gas does the cylinder hold? So just like always, we're going to go through and write down our variables. So my steel cylinder has a volume of 25 liters. It's already in liters, so we don't actually have to convert. That's good. So my volume is 25 liters. It says my pressure is 200 atmospheres. And my temperature is 27 degrees Celsius. Because it's in Celsius, we're going to have to convert to Kelvin by adding 273, which will get you 300 Kelvin. And it says, how many moles of nitrogen gas does the cylinder hold? So what we're looking for here is N. That's my moles. Then let's write down the equation, PV equals nRT, and we'll start plugging stuff in. So over here, my P was 200 atmospheres. My V is 25 liters. N is what I'm looking for. Okay, R. R has 3 different options here. So what we're going to do is we're going to go look at what my unit of pressure was. So my pressure is in atmospheres. Because my pressure is in atmospheres, I'm going to use this R value, this 0.0821. Because pressure is in atmospheres. So just be careful with that. Last thing is my temperature, which we said was 300 Kelvin. So to solve for N, the first thing I would do is combine these numbers. So I'm going to do 200 atmospheres times 25 liters, which will get you 5,000. Set that equal to N times the product of these two, 0.0821 times 300, which will get you 24.63. Last step is I'm going to divide both sides by 24.63. That way I get N all by himself. When I do this math, 5,000 divided by 24.63, you should get about 203 moles. That's going to be your N. That's your final answer here. Question number 2 says, how much pressure in kPa can be created in a 2-liter soda bottle if you use a 1/4 pound or 114 grams of dry ice? Let's assume you did this in the afternoon when the temperature was 30 degrees C. So let's break this down. We want to know how much pressure in kPa. So that's what I'm looking for. Pressure is what? Units are in kPa. That's important for our R value later. Can be created in a 2-liter soda bottle. So 2 liter would be my volume. If you use a 1/4 pound, okay, we never ever use pounds in science, so I know I'm not using that, or 114 grams. 114 grams we can use. However, grams is nowhere in this equation. So we have to convert from moles into grams, which we do know how to do. So we're going to go ahead and do that right quick. So I'm going to convert the grams they give me into moles using molar mass, just like we've been doing since February. So if we look at this, I want to know how many moles of dry ice, which is CO2, is equal to this 114 grams of CO2. So I'm going to use the molar mass of CO2. So to get the molar mass, you take the number of atoms of carbon, which is 1 carbon atom, times the atomic mass from the periodic table of carbon is 12, plus you've got 2 oxygen atoms times atomic mass of oxygen is 16 from your periodic table. When you put that together, you're going to get 44 grams per mole. When we plug that in here, my 44 grams, sorry, I kind of squished this, 44 grams has to go on bottom because I want my grams to cancel, and my 1 mole will go on top. So all I need to do is 114 divided by 44, which will get you 2.59 moles of CO2. So make sure you do that extra step. You can't plug in grams, you have to plug in moles. After that, it says, blah, 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 the temperature was 30 degrees C. Again, it can't be in Celsius, it has to be in Kelvin, so make sure you add your 273, which will get you 303 Kelvin. Then it's just all about plugging this in. So our equation is PV equals nRT. My pressure, we don't know, that's what we're solving for. My volume is 2 liters. My moles, we said, was 2.59 moles. My R value depends on my pressure. So it says we want our pressure in kilopascals. So if we go up here, if my pressure is in kPa, then my R value is this number, 8.31. That's my R because the pressure is in kPa. Then last is the temperature, which is 303 Kelvin. So all we need to do here is divide over this 2 liters to get rid of it on the left. And then just plug in the math. So when we do this math, 2.59 times 8.31 times 303 divided by 2, you will get a big number, 3,260.7 kilopascals. That's your final answer. Okay, last problem. Number 3, an adult has a lung capacity of 4.2 liters. How many grams of air do your lungs hold at the beach where the pressure is 760 millimeters mercury and your body is 37 degrees Celsius? Assume 1 mole of air has a mass of 29 grams. So let's break that down. Adult has a lung capacity of 4.2 liters. That's a volume. How many grams of air? Okay, here's a problem because we can't get grams directly from the equation, but we can get moles. So we can convert from moles into grams. So for now, we're going to figure out moles, and then at the end, we'll convert it into grams. Where the pressure is this, 760. So my P equals 760 millimeters of mercury. And my body temperature here is 37 degrees C. So my temperature, 37 degrees C. Make sure you add your 273 to get to 310 Kelvin. Then it says assume 1 mole of air has a mass of 29 grams. So we're going to wait. We're going to use that when in our final step when we are converting the moles into grams. Okay, so let's plug everything in. My pressure was 760 millimeters mercury. My volume, it said, was 4.2 liters. My N, I don't know. My R value, we're going to go look at the pressure. My pressure is in millimeters of mercury. So if we go look up here, it says if your pressure is in millimeters mercury, your R is going to be 62.4. Because pressure is millimeters of mercury. And then my temperature was 310 Kelvin. So let's combine some of these numbers. On the left, I'm going to do 760 times 4.2, which will get you 3,192 on the left, is equal to n. If we do 62.4 times 310, you're going to get 19344. Then to isolate for n, I'm just going to divide both sides by this number. When you do that math, 3192 divided by 19344 gets you about 0.17 moles is n. Okay, that's not your final answer though, so don't box that and be all excited, because the question is asking for grams of air. So we need to convert this moles of air into grams of air. How? We're going to use this conversion here. So I want to know how many grams of air is equal to this many moles, what we solved for, 0.17 moles. The way I'm going to convert from moles of air to grams of air is using this. This guy says that, well, 1 mole of air has 29 grams. So we want to know if 1 mole has 29 grams, how many grams is 0.17 moles? So I'm going to put this 1 mole on bottom, because it says that 1 mole equals 29 grams. I put the 29 on top because mole on top, mole on bottom has to cancel, which leaves us in grams. So when we do 0.17 times 29, you should get a total of 4.9 grams of air. That's your final answer. Okay, so now you should be prepared for the practice problems. If you still have questions, reach out to me, and have a great day.